everyone, in this video we are going to discuss that Google has opened API access to their Gemini Pro model and you can use it for testing for absolutely free. Gemini provides a number of integrations with different large language model platforms which include LangChain, Llama Index and many others which you can see over here as well. In this video we'll learn how we can chat with multiple documents using the power of LangChain and Gemini Pro model. So let's get started with it. As you can see the Google Colab notebook. So in the first step we will install all the required packages which you can see over here. As I told you that we will be using LangChain to implement, we will using Gemini Pro model within the LangChain framework. So I will just install LangChain Google generative AI. Then we have Python environment. Basically, we require this package so that we can load our API key. I will be using Gemini Pro model within the LangChain framework. So from Google.generative AI, we are importing generative AI, and from Google.colab, import user data so that we can securely secure our API key over here. Okay. Then we have from .environment import load .environment so that .environment package we can load the API key, and to display any input image in the Google Colab notebook or any output image in the Google Colab notebook, we import display library. Then we have markdown so that we can just format the text into a very nice format using markdown package. And then we have the text wrap library. Okay, so let's import all the libraries. Then we set up our API key. So if you haven't got your Gemini Pro model API key, you can just click the link over here and you can just redirect to the site which is provided over here. So you can just go to the Google AI Studio, and our Gemini Pro model API key is available under MakerSuite. So you can simply click on create a new API key, new project, and you will be able to create the API key. You can see that I have created different API keys which I'm using in my different projects. Okay, so you can see user data.get Gemini Pro key. So if I just go over here, you can see in the secret tab I have just passed my API key. If I just open this, you can see the API key. I just go over here again. If you just click over here and generate a new API key, so this might take few seconds. So you can simply copy this from here. Okay, and what you can do from here is you can click on add new secret key, and whatever name you can write over here, please remember that name. So this will be the name of your environment variable. So we can simply write the same name over here. So you can just copy this and write the same name, and you can just copy this API key from here and you can just add that API key, and you can just hide this API key. Okay, and you can just make it able to access from the notebook. So in this way you can see how it works. Okay, so if you want to add some other secret key, you can add new secret key as well, and you can delete it as well. So I have already added two secret keys over here, and please remember that name. So this will be the name of your environment variable. We are just setting our API key, and now we will just create a new environment file in the workplace over here, and we will store the API key in it. So now you can see that what we have the API key. So I will just copy this from here. Now you can see .environment file has been created in the workplace, and we have stored our API key in it. So now we are just creating a function to dash markdown. When we get a response from the Gemini Pro model, we will just convert the response into a nicely formatted text. That's why I created this function. Now I will just generate a list of models that are available provided by Gemini Pro model. So I will just publish a list of different Gemini Pro models. You can see we have the Gemini Pro and Gemini Pro Vision. If you want to input text and generate a text response, then we can use Gemini Pro model. And if we want to have an input in the form of text or image, then we can use Gemini Pro Vision model. If you have input in the form of text and image, then you should use Gemini Pro Vision model. Okay, from generative AI, I'm using the generative model function, and here I'm just using the Gemini Pro model because I'm just passing my input, which is in the form of text, not in the image. So I just read the first input, and here it will just calculate a time it takes to generate the response, and to print the response we will just write response dot text key, so this will generate the response. Here we have the two dash markdown. You can see that this is the response generated by the Gemini Pro model, but to make this response look in a nice format, we can just use response dot text. You can see that this response is now in a very well format, so it looks a good response. Currently, you can see that we have not used LangChain framework to generate response or text response based on the question that we have just asked over here. Now we will just use LangChain to assess Gemini Pro model. So previously we are just donating the text response directly using the Gemini Pro model. So now we will use LangChain to assess the Gemini Pro model. So first we will do is what we can generate text from the text input. Here you can just see from LangChain Google Generative AI. I'm just importing chat Google Generative AI. You can see that I'm just initializing my Gemini Pro model and using llm.invoke. I'm just passing the question, what is mean average precision? So basically, mean average precision is a metric that is used to evaluate any object detection model. So mean average precision is a metric that we usually use when we try to evaluate any object detection model like YOLO V8, YOLO V7. So now we are just using LangChain framework to assess the Gemini Pro model. As you can see, we have the response mean average precision, a widely used evaluation metric in object detection and image classification task. It measures the average precision of model prediction across all classes. It's a good response. Previously, we used LangChain to assess Gemini Pro model. Now we will use LangChain to assess Gemini Pro Vision model. So in the Gemini Pro Vision model, we generate text from image and text input. So in Gemini Pro Vision model, we do two things. We provide input in the form of text and images. So in Gemini Pro, we only provide text as input, while when we are using Gemini Pro Vision model, our input is in the form of text and image as well. So basically, Gemini Pro Vision model is a multi-model model provided by Gemini that can handle input both in the form of text and images. Okay, so I have just written this function so that I can just display the input image. So the input to this function will be the URL of the image. Here you can see that this is the URL of this image, and I have just passed the URL of the image, and we are just using the display library which we have imported at the start. I just displaying the input image into the Google Colab notebook. Okay, this is the input image. Now we will be passing this image as an input to our Gemini Pro Vision model. You can see over here from LangChain dash core dot messages I am putting human message, and from LangChain dash Google dash generative AI I'm just importing chat Google generative AI. And here you can see I'm just passing Gemini Pro Vision model. As you can see there, we have a different type of structure of input. We have two different dictionaries over here, and first we are passing the type of the input is that in the form of text, and our text is what is in this image, and we are just passing this image our URL over here as an input, a snow cap mountain, a sunset. So now you can see the sunset is going on, and you can see a snow cap mountain over here. You can see a snow cap mountain at sunset, so it has given the response. I have another image. There are different vegetables and rice and put. We can see different vegetables over here in this image. So let's pass this image as an input to my Gemini Pro Vision model. So I will just write text. So write a detailed blog post based on this picture, which I'm just showing you over here. Make sure to cover each and every aspect in the blog post, and I'm just passing this image URL as an input through my Gemini Pro Vision model. Okay, so now you can see we have the response. So you can see that there are different vegetables and brown rice I can see in this image, so it has generated a response over here. So I have just passed the input as a detailed blog post based on this picture. Make sure to cover each and every aspect in the blog post. So the response is, you are looking for a healthy and delicious meal preparation idea, look no further. So it has given me like can generate this type of meal using the ingredients which we have currently, and it has to make this meal you will need the following ingredients, and it has provided instructions like how I can prepare this meal. So that's look good. So now we have seen that how we can use LangChain framework to use Gemini Pro and Gemini Pro vision model. We have used LangChain framework to assess the Gemini Pro and Gemini Pro vision model, and we can see that we are just getting very good results as well. So now chat with documents. We will learn how we can chat with documents using LangChain and Gemini Pro vision model. So we will learn how we can chat with different documents using LangChain and Gemini Pro vision model. First, I will install all the required packages. So I require LangChain as we are using LangChain and framework to chat with our documents, and then we have PyPDF so that I can load the PDF file and extract the data from those PDF files. So then we have ChromaDB because we are using ChromaDB as our vector database. We are importing prompt template, so we'll just pass an input prompt. Okay, in large language model, we do not pass our question directly to a large language model. We pass our question in our prompt template, and then we pass the prompt template to the large language model, and let's import all these required libraries. Then we have load QA chain so that we can establish a question answer chain, and we can chat with the documents, and then we have PyPDF directory loader so that we can upload all the PDF files that we have in our directory. Then we have recursive character text splitter so that I can split my text into small chunks. We will use PyPDF reader recursive character text splitter so that we can split our data into small chunks. Then we have Chroma, which is our vector database. Now I will be just creating a folder by the name of PDFs, and inside this folder I will just add all the PDF files. So I'm directly downloading the PDF file from my Google Drive into this Google Colab notebook, and the PDF files will be added in the PDF folder which we have created. You can see here we have both of the PDF files. Now using PyPDF directory loader, I will just load the PDF files and extract the data from those PDF files. So using load and split, we will split that PDF files into different pages, or we will extract it or we will extra split that extracted data, the data which we have extracted from the PDF files, into different pages. You can see that on the page number 3, like it starts with 0123. On the page number 3 we have this data, and this is all the data which we have extracted from the PDF file. So this is a huge amount of data. So now let's see the number of words which we have in our that data which we extracted from the PDF file. Like we have seen that the input token limit of Gemini Pro model is 32,000 tokens, and if you just see 1000 token is equal to 750 words, so Gemini Pro model can handle 24,000 words at the input. Now using recursive character text splitter, we are just splitting our data into small chunks, and the chunk limit is 15,000 English characters. So each chunk has an input limit, like there are the number of characters that can be stored in each of the text chunk, which will have maximum 15,000 English characters, and there will be an overlap of 100 English characters among each of the text chunks. So you can see we have created different text chunks. So we have split it our extracted data into these different text chunks, and this is the data which I have in the text chunk number 2. Okay, now I will just download embeddings from Google also provide an embedding model as well. Now we will create embeddings for each of the text chunk, and we save them into a vector store. So I will just ask a question, how are humans intelligent? You can see that there is a lot of responses that are generated. So here is the prompt template, and I am just passing the prompt template. Answer the question as detailed as possible from the provided context. Make sure to provide all the details. If the answer is not provided in the context, just say answer not available and don't provide the answer. So if we don't have the answer available in the PDF file, I'm asking my Gemini Pro model to do not give me the wrong answer. Just the answer is not available in the PDF files. I'm just passing this documentation as context, and the question which I have asked as how are humans intelligent. So both of these things, talks and questions, are passed in an input. In this video, we have seen that we can access a Gemini Pro model with LangChain. So we have also seen how we can access Gemini Pro model vision with LangChain, and we have seen that how we can chat with multiple documents or PDFs using the power of LangChain, ChromaDB and Gemini Pro model. So that's all from this video. I hope you all learned something. Thank you for watching. See you all in the next video.